Good afternoon, everyone. Welcome to today's session on smart contracts. I am excited to guide you through this fascinating subject. Let's dive right in. So, to start, let's understand what a smart contract is. A smart contract is a self executing contract with the terms of the agreement directly written into code. These contracts are automatically enforcing and executing the terms of the agreement without the need for intermediaries. They exist on blockchain networks, making them tamper proof and transparent. Now let's understand how do these smart contracts work. Smart contracts work by running code when predetermined conditions are met. Think of them as digital if-then statements. For example, if a person A sends 1 Ethereum to person B, then realize the digital asset to person A. This process is decentralized with multiple nodes verifying and executing the smart contract. So the three steps involved are writing the smart contract in Solidity code for the EVM based blockchains, deploying them to a blockchain, and then they are executed by the EVM, that is the Ethereum virtual. Now let's move on to the key features of smart contracts. Smart contracts include automation, security, transparency, and immutability. Once deployed, the contract cannot be altered, ensuring that all parties adhere to the agreed upon terms. Additionally, since the contract is on a blockchain, it is visible to all participants, promoting trust and transparency. Once deployed, contracts cannot be changed. Moving on to the benefits of smart contracts. Smart contracts offer numerous benefits. They eliminate the need for intermediaries, reducing costs and increasing efficiency. Their automated nature speeds up processes, and their immutable and transparent nature enhances trust and security. These characteristics make them ideal for a wide range of applications. Moving on to the use cases of smart contracts in finance. In finance, smart contracts streamline processes like loan issuance, insurance claims, and trading. For instance, in trading, a smart contract can automatically execute trades when certain conditions are met, reducing the risk of human error and increasing transaction speed. It also automates lending platforms without banks because in today's world, banks cannot be trusted. And also enhances direct peer-to-peer payments instantly settled. Moving on to the use cases of supply chain. In supply chain, smart contracts improve transparency and efficiency. They can track goods from origin to destination, ensuring authenticity and timely delivery. This reduces frauds and errors as each step is recorded on the blockchain and is accessible in real time. As you can see here on this slide, there are all the steps listed where you can use smart contracts. Moving on to the use case of smart contracts in real estate field. In real estate, smart contracts simplify transactions and property management. They can automate the sale process by handling payments, transferring ownership, and updating records seamlessly. This reduces paperwork, speeds up the transactions, and ensures transparency in property deals. We can also automate the process of rental payments and deposits and securely secure the digital records of property ownership. Moving on to the voting use case. Smart contracts also revolutionize voting systems. By recording votes on the blockchain, they ensure transparency, security, and tamper-proof results. This can increase voter trust and participation, as each vote is publicly verifiable and cannot be altered once cast. This also prevents the political parties from shouting that the EVM machines are tampered with, and can also help in real-time tracking of vote counts, thus reducing the time between the election results and the election casting votes day. Moving on to the languages that are used in drafting smart contracts. These include Solidity, which is the most popular language right now for Ethereum based contracts, Viper, Rust for Solana based smart contracts. Each language has its syntax and features tailored to specific blockchain platforms. Languages also include EVM bytecode, that is low level bytecode that EVM directly executes. Moving on to the next topic, that is the testing of smart contracts. This involves four types of testing, that is unit testing, integration testing, security audits, and test networks. Testing smart contracts is crucial to ensure that they work correctly. Unit tests verify individual functions, while integration tests check how different parts of the smart contract work together. Additionally, formal verification mathematically proves the correctness of the contract code, enhancing security, that is the security audits. And before deploying the contracts on the mainnet, we must deploy them to the test nets to actually check that how they work in the real-time blockchains. Now, moving on to the next topic, that is the security of blockchains. Security is a top priority in smart. Common vulnerabilities include re-entry attacks, integer overflow, and unauthorized access. Developers must use secure coding practices, thorough testing, and code audits to mitigate these risks and protect users' assets. We can also include bug bounties, that is, incentivizing bug identification by security researchers, and also upgradable contracts, that is, architecture allowing secure code updates. Moving on to the next topic, that is smart contract standard. Smart contract standards ensure interoperability and security. The most well known standard is ERC20 for fungible tokens on Ethereum. ERC721 is used for non fungible tokens, that is popularly known as NFTs, and ERC1155 is also a multi token standard for supporting for both fungible and non fungible tokens. These standards ensure that contracts adhere to a common set of rules, facilitating broader adoption. Moving on to the development part of smart contracts. To develop smart contracts, various tools are available, TruffleSuite being one of them, which offers a development environment, testing framework, and asset pipeline for Ethereum. Remix ID is a browser-based tool for writing, testing, and deploying smart contracts on testnet. OpenZeppelin is a library of secure, usable smart contract codes which is already written by a bunch of programmers, whereas Etherscan being a search engine for exploring deployed smart contracts written by users worldwide. Moving on to the future of smart contracts. Looking to the future, smart contracts hold immense potential. They can automate complex processes across various industries, enhancing efficiency and trust. However, ethical considerations such as ensuring fairness, preventing misuse, and addressing legal implications must be carefully managed. We must also look at the concern of scalability of these smart contracts, that is, improving their transaction speeds and throughput. We must also improve the interoperability aspect of smart contracts, that is, make smart contracts using languages that are cross-chain compatible between EVM-based chains and Solana-based chains, and many more. Despite their benefits, smart contracts face challenges. Bugs in the code can lead to significant financial losses, and their immutable nature means errors cannot be easily corrected. Moreover, legal and regulatory uncertainties surrounding smart contracts can pose additional risk. We also have a lack of privacy, which is because all data and code is public on blockchain. Oracle issues, that is, reliance on external data sources which supply the blockchain with real-time data from throughout the world, because a blockchain cannot interact with the external environment on its own. Moving on to the smart contract ethics. Looking to the future, smart contracts hold immense potential. They can automate complex processes across various industries, enhancing efficiency and trust. However, ethical considerations must be carefully managed, like decentralization, identity management, social impact, and environmental impact. Decentralization promotes fairness and reduces the risk of single points of failure. It empowers users by eliminating centralized work control, but it also presents challenges in governance and consensus mechanisms. Smart contracts can enhance identity management by providing secure, decentralized identity solutions. This can also help protect privacy and reduce identity fraud, but it also raises concerns about the data sovereignty and access control. The widespread adoption of smart contracts can drive social change by enabling more transparent and efficient systems. However, it is crucial to ensure that these technologies do not exacerbate inequalities or exclude disadvantaged groups. Sustainable practices and the adoption of more eco-friendly consensus algorithms like proof of stake are essential to minimize environmental impact. Moving on to the resources for smart contracts development. For books, you can refer to Mastering Ethereum, Introducing Ethereum and Solidity. For courses, you can go to Coursera, Udemy, and many more. You should also join various communities which are on Reddit, Discord, Telegram groups, which also post regular information about Web3 and drafting smart contracts and various new technologies in it. Also, you can check out the documentation for developing smart contracts and Solidity, developer tools, and etc. Thank you all for joining today's session on smart contracts. I hope you found it informative and engaging. Feel free to reach out with any questions. Have a great day.